welcome back to the Future of Mining podcast. I'm your host, John Varson, and today we're at Aachen University, where we'll be meeting with Professor Tobias Vraetz at the Institute for Advanced Mineral Processing Technologies. And he's going to be telling us all about his institute, giving us a tour, and telling us a little bit about how the institute is collaborating with industry and how that fits with the education and the future scientific development and research of the institute. So I'm looking forward to meeting him, and you can follow me and let's get started.
Welcome to the AMR here in Aachen, the university. My name is Tobias Vraetz. I started here approximately 1.5 years ago as a professor for advanced mineral processing technologies, and I'm happy to host you today for this little tour to the Institute and Technical Center. Well, let's start over here. Like I said before, we have here the building on our own. A couple of specimen and samples from previous testing for different applications. Just a few like salt, like gypsum, some metals over here, obviously some gold, just to name a few. And what is currently being also very attractive in our projects is, for instance, the hematite ore and then other iron ores that you can see over here.
And is that all done, extracted locally, or is that
that's from all over the world. Where are the
ore bodies from?
That's from all over the world. Like here you have one from Sweden, from Kiruna. This is locally from Germany, South Africa, Canada, just to Australia, Austria over there, this azurit, or Kazakhstan, Peru, and that is very locally. This is from a quarry just here next door to Aachen. So yeah.
Oh, that's cool.
Basically local, but also global.
Yeah.
Specimen.
But the gold is not local, right?
No, this is South Africa, Witwatersrand, South Africa. And then I have to say they are also being brought probably by my predecessors, for instance by Professor Wotruba, whom I'm following up on.
So I see some toothpaste there.
Yes, indeed.
What's the story with the toothpaste?
It's in that sense funny that you name it, because just making short relationship, my daughter's also asking that when she visited me the first time, and she said, "Hey, why are you having toothpaste over here?" And this type of fluoride is part of this toothpaste. As you probably know, fluor as the element is part of toothpaste, and as such, this one is from southern Germany part, a deposit that we just visited last year with an excursion of students. And therefore, yes, we also have toothpaste over here, cool. as you see.
And table salt, which is another thing that we use every day, right? And
yes.
That's quite strong in Germany, right? There's lots of salt mining.
Indeed. I'm not 100% sure where we are in the global range, but as far as I remember, we are at least in the top 5, if I'm not mistaken. So this one is also from a local, kind of local North Rhine-Westphalia deposit in Board operated by company K+S. And as you see, normally the salt's coming out of the rock like this in that particle size. And that's why we are here, right? Why we are in the Mineral Processing Institute, where we produce salt to be put on French fries, to be used for the winter time. All right.
Right, let's keep moving.
Let's keep moving to the technical center. Yes, and then we enter the technical center over here. And as you see, it's a busy place. So over here you see a lot of specimen, a lot of different projects that I can recognize while looking on the probe's names. So what is currently pretty attractive in terms of research and development projects, also in the field of mineral processing, let's say besides the traditional commodities, gold ore, iron ore, copper ore, and so on and so forth. You see here also materials, for instance, clays on that hand side. Then you see here on the right hand side also slags. So it's not necessarily the traditional primary raw materials, it's kind of a secondary raw material, right? Slags from production processes.
What's been going on with these containers here, or these, looks like they've been mixing or sorting something?
There is different things that we are doing over here. So if we talk about clays, then we are doing, for instance, LOIs over here for giving an indication about the, let's say, of the calcination process, but just an indication, not very scientific, deep analysis. On that hand side, I'm actually not 100% sure what is being done over here, but it looks like they are coming out of a drying process. So they have been processed before, have been dried, and now I guess they will be further processed here in the lab or in the analytical lab, where we have the screen towers and where we have a small mill over here on the right hand side. So I assume that later on today we will see some people doing some stuff over here.
And
also hands-on.
what's this arm that's sticking down here? Is this some sort of ventilation system?
Yes, it's a kind of boring unit for us, but very necessary for doing experiments. It's a dedusting unit over here. So if we talk about sizes in the micron range, we also have to deal with the dust that is exposed from the experiments. And as such, we have all those lines. Also, you will see them later on down the stairs, where you have the dedusting unit connected to.
So we need to be safe, right?
Yes, indeed, a safety measure. So what you can see over here is Ivan, our postdoc, who's currently homogenizing lithium ore. So also very industrial, close project that we are running over here. And working at materials for future battery supply. All right. Let's continue the walk over here. Like I said, various screens that you can see over here. The screen tower next to it, where we do the experiments actually. Like I said, I'm pretty sure...
And that's just vibrating the material, and then it gets finer as it goes.
Indeed, you have various of those screen decks. You will combine them according to your requirements, and then this one is shaking and vibrating, and as such you will get the products out of the...
What have we got over here?
Over here, this is I have to think about the English term for it. It's basically also kind of a exhausting unit. No, what is it called? Where you have to, if you deal with chemicals, if you deal with materials that are not safe to breathe in, then you need that device.
So you can do the experiment
inside the housing, indeed.
All the air is filtered out.
Indeed, yes. Couple of ovens or furnaces over here. For instance, like I said, when we do the LOIs, when we have to dry materials, we can have a look over here. Let's just give it a look. Like you see, there is last specimen.
There's quite a bit of heat coming out of this.
Yes, it is 100 degrees Celsius if you can see it over
105.
here. Yes, but there's one part of the specimen that you saw earlier on the table.
This one is not on?
That's not operated right now. That came just back from an experiment that we did last week outside the AMR. And maybe one equipment that we also can showcase. So we have magnetic separation over here. And I will explain that to you maybe with some specimen. All right, what you can see over here is a magnetic separator in a very small scale, which we use for doing first assessment on whether material can be magnetically separated or not. So the material is fed by a vibratory feeder here at the top. It's then being brought here to that drum where the magnet is inside. We have the opportunity to play a little bit with the speeds and with the magnetic coil current, and as such, like I said, we can do a first assessment. And like you can see over here in those two buckets, you see on the right hand side some very white material. In that sense, it is a quartz sand material. And here on the left hand side in the bucket you see a black material, which is actually the magnetic material because it sticks to the roll and then it's being dumped over here into the second bucket. Yes, so let's follow me into the basement. And like you see over here, so over here we see the other part of the technical center with various devices, various equipments that we operate. I mean, the AMR has approximately 70 pieces of the equipment, what we can do or what we can use in terms of testing it and doing experiments. Over here we see a jigging machine for testing density sorting in various ways, and also been operated for a couple of years already. Next to the jigging machine you see a small HPGR So a small high pressure grinding roll where we can do experiments over here, followed by another dedusting unit and a jaw crusher. Yeah, so this on the left-hand side is at the moment under maintenance. We have a technical center lead that is doing the job over here for maintenance, for repairing jobs, also supporting the students as well as the PhDs to operate the machines. Not saying 24/7, but at least keeping them alive and keeping them running, basically.
Yeah, you've got a lot of equipment here, so I imagine things break down, but they also just need regular maintenance, right?
Indeed. We can also make use of a workshop next to that building here, which is responsible for the entire institutes for mining and recycling here in Aachen. But yeah, for the small stuff, our technical lead is very capable of doing that on its own.
And you got a little sign here saying moving machinery.
Indeed.
It's moving by itself, or
be careful.
Somebody had to work.
Be careful, indeed. I guess this has been brought from South Africa, if I'm not mistaken. And if I interpret the first two lines in Dutch correctly, or in Afrikaans, I guess.
Afrikaans, yeah.
Indeed. So yeah, like a souvenir from one of the excursions that have been done in the past.
Nice.
A small magnetic separator, so-called Gauss-Tech separator, actually been in operation for an experiment on hematite ore. So yeah, like I said, these equipments are already quite some years on their back, but yeah, still in operation.
How long does the equipment last for typically? Here, and how do you get it? Like, is it gifted to the university? Do you have to acquire it?
Well, there are different ways of getting equipment. For instance, we are applying for different funding projects, and in the funding projects you can apply for equipment to be inserted or included into this project. Some equipments have been provided to the university as a gift. So yeah, and as such, the technical center grow over decades.
Yeah, already so under more space, right?
Under my predecessor, indeed.
And the maintenance becomes more and more important.
Indeed. So, two guys actually working on experiments here within the technical center. Yeah, and some auxiliary equipment for crushing, for grinding, for screening upstairs. We saw already.
And you got a
conveyor
conveyor belt here for that's all connected, right? So
indeed, this is a circle. So we do experiments in a loop. So material has been fed, and then being separated here by the separator, and then it's been brought back, and there's a continuous process. Usually
goes back up through there.
Yes, usually we do batch testing here in the technical center. So yeah, we don't run complete processes so that we connect one crusher with a conveyor belt to another screen or something. We are doing that batch-wise, but we are able to produce up to 1 ton per hour of material with some of the equipments. Not with all, but with some of the equipments we achieve that 1 ton per hour capacity.
It's pretty good. So where are we going next? What's the next?
Maybe last but not least, I will have to check what is happening over here. It sounds like some experiment is kind of running. I guess here is a cleaning job being done. You see here on the left-hand side a shaking table, which is usually been used in gold operations for the density sorting to separate the gold particles from the gangue material. And at the moment, like I said, this is more a cleaning operation right now, but also shows the benefit over here. We are able to work with water. And as probably each mining student should know, a lot of processes in mineral processing are being done under water conditions.
So water treatments are really important.
And water treatment is a real important part for mineral processing engineers to take care of.
And circulation, right?
Indeed. I guess this is more or less the technical the technical center. And, there is a last piece over there upstairs, and that's the flotation lab. So let's go to the flotation lab. So over here, this is the flotation lab of AMR with various flotation cells that we operate, and also with one dedicated postdoc that is running that lab and has been responsible for the experiments that are being done over here. I'm actually not sure whether we do an experiment today, so I have to check that as well, whether that makes sense to take a shot of it. But here is all the capabilities that we do have to do investigations and experiments.
So these look like giant kitchen mixing machines.
Yeah, indeed, it's not that far away. So these are so-called Denver cells, and those Denver cells, they are kind of mixing machines. So you have that mixer over here. There is an air supply that is going to the bottom of that mixer. Basically, you put in the material into such a bucket over here, just as an example. Obviously, it's a little bit bigger when we do the experiment. And then the mixer is turning, or the agitator is turning. The air is being filled through the slurry with the particles inside. And some particles dock to the air bubbles, and others are not docking to the air bubbles. And as such, we can separate material A from material B with the flotation.
Which is what the processing is all about, right? It's separation.
Indeed, it's about separation, and basically it's about crushing, screening, and then separation.
Yeah. You're not converting one material to another. You're separating it from each other so that you can create a practical use case, right?
Indeed, and usually what we do is we separate it, and when we hand it over, for instance, to the metallurgical experts or the construction industry to process and use it further. Some analytical...
And it's all small scale when you compare it to like a full mining operation. These things are just magnified. It's the same concept but magnified.
Indeed. Indeed, and we have to say what we are looking at is often the methodologies, right? And we will come to that probably later on in the podcast as well, or in the interview. Here at the university, it's not about building the products at the end of the day, but building the methodologies to come to the products. And as such, we are working in a small scale, like I said, up to 1 ton per hour. It's not purely a lab, but also technical center. That's why I'm calling it like that. But the next step then is to scale up into prototype scale or into the scale of the mining operation itself.
Yeah. So what fundamental knowledge do the students gain from taking this program, this course with you that they wouldn't get at kind of a normal university engineering degree?
I think, I can only speak for Aachen, obviously, but I think we do have a very practical education over here. As you see, we have, like I said, 70 pieces of equipment, and our research and development work, as well as the teaching and educational lectures, they are always being connected to practical work, right? So if
there's a real good connection to the industrial use.
Yes.
Yeah. And when you're doing experiments, are they kind of breaking new ground? Are you developing new science at the same time?
This is difficult to answer.
Teaching?
No, it's both. It's practical teaching as well as finding new results and science.
New innovative solutions for the established problems. Right?
Science can be in both directions, right? You can find out that something is not going to work, but it's a science as well. And you can find out that something is going to work, and that is what motivates us here to work on practical industrial related problems or challenges, I have to say, and to find solutions to overcome those challenges. And sometimes also the industrial partners here in Germany. We're very close to the Ruhr area, for instance, so there is quite some OEMs, there is quite some machine builders very close to that location over here what we are collaborating with, and they come up with those questions and those challenges.
And then you can experiment to see, is it valid, is it a viable opportunity or not?
Yeah. And just while being here in the flotation lab, that is also something. So flotation and finding the right mix of reagencies is something, if I'm allowed to compare that, cooking a soup. So you have various recipes to do flotation experiments and do the flotation and mirror processing, and we are here to find out what reagencies works best and what experiments can support the later on implementation in the real world.
So if you use the soup analogy, when you're making a soup, you're combining things to bring it to one whole. In mining separation, you're taking a whole and adding some new ingredient to help it come into its separate parts out of each other.
it's quite a nice analogy. So, like I said, for the flotation, it's really like cooking the soup, right, and putting ingredients and stuff in. And for the overall mineral processing process, it's more like going the other way around. So, what do we need to extract something and to extract the valuable materials and to separate valuable from unvaluable, or even to extract or separate a material A from material B? Because most often we have for instance, polymetallic deposits, and we have to extract, for instance, copper from zinc, from lead, and get the most out of those deposits, and not only focusing on one ore, for instance. If you look at this thing over here, you see a X-ray detection device. It's part of our sensor-based sorting investigations that we usually do. So this device is a little bit like your hand luggage scanner on the airport or at the dentist, right? When your tooth will be investigated, and that one is investigating rocks, basically. So usually we take some of those specimen over here, and with those specimen we do tests. And with those tests, we can determine the density of the material, and those equipment is often used in, for instance, in kimberlite.
So you need to keep all those samples separated from each other.
Yes, you have to do a separation of them before, then we put them into this device, and then we can do a scan. And with that scan, we can investigate on the different density distributions within that rock. And then we can investigate on whether we could sort them by density separation or we can't. Furthermore, we can do obviously the check on the sensor-based ore sorting without sorting them actually, because it's just a detection device. But what we can also do, and often has been done in those research projects, is the investigation and benchmarking between physical separation methods, like for instance the jig, or sensor-based methods, and that is something we can do here very independently, so we are not directly connected to the suppliers, to the OEMs, so we can do quite a nice benchmark analysis for this density separation.
And when it gets to a commercial environment, they would use the same type of technology, but they would put it in some sort of sorting environment, right?
So the detector, close to correct. Yes, we do have the same technology inside from a detection and receiving device, but this one is this one is very accurate. So nowadays, as far as I know, the detection speed is much higher than the separation speed and the calculation speed of the computers to get that connected.
Okay.
So this one usually has a bit of a higher resolution than the sorters that are available in industry. But from the principal point of view, it's the same technology. Just connected here, or just not connected here to the sorting device.
So is there anything else you want to show us in the...
I think that's all here from the technical center.
Thank you very much for the tour. But we've still got some questions for you. So let's jump back to the studio and we can ask you some more questions. Thank you, Tobias, for joining us today, and we really appreciate it. Today we're going to talk about your new role at RWTH Aachen and how it interacts with the European mining course and the importance of material processing in the workflow and the life cycle of mining and extracting, taking the extracted goods and turning it into something that we can actually find useful. But perhaps before we get started, you could tell us a bit about yourself and what your role is here.
All right, thank you very much, John, for inviting me to that podcast. My name is Tobias Vraetz, as you already mentioned. I'm a mining engineer per education. Did my studies over here in Aachen approximately 15 years ago. Then did a PhD on an institute here of the Mining Institutes just afterwards, and then went very classically into industry, joining two companies. First Royal IHC in the Netherlands, and afterwards Weir Minerals, a global provider of comminution and processing equipment as well in the Netherlands. Subsequently, in 2024, I came back to Aachen University as the head of and professor for advanced mineral processing technologies, and since then I'm back here.
There are a few mining and processing related institutes here at the university. Perhaps you could explain where you fit in, or where they all fit into each other, and where your institute fits in.
Yes. I think we are in Aachen able to capture the entire value chain of mining and raw materials extraction, processing, and making valuable products out of it. So we have different institutes, which starts with the exploration, even with the geologists, etc. We do have the institutes that are focusing on the mining process itself, being that the exploration, being that the transportation, as well as digitization, electrification, and automation. And then I guess my institute fits pretty well into the part of the processing and turning those extracted raw materials into the first sellable products. Whether it then also here at Aachen University can be followed up on, for instance, in the metallurgy, or also nowadays in the construction industry or institutes related to that discipline.
Yeah, and then you also capture the material in its second life, right, with the recycling technologies and...
Indeed, we are trying to close the circle, also in terms of circular economy, and so we are also having institutes really focusing and specialized in circular economy aspects, as well as recycling of materials and, for instance, energy supply to the market.
So when most people think about mining, they have this visualization of a large open pit mine in Australia or in Africa. But they don't really understand the importance or the critical role that the processing plant has to play in turning those raw materials into something that we can use. Perhaps you can explain the role of the processing plant and why mineral processing is so important.
So any product is starting with raw materials. And as such, if we consider Germany especially, then in the past I experienced myself the feedback of friends and family, hey, you're doing mining. And what is that all about? Is it all about coal mining? No, it isn't. It is more than that. It's about construction materials. For instance, you have been to Aachen this morning on a road as well. We are all living in nice houses. We are in that building of that university. So you need construction materials for doing that stuff. Besides that, we are in an energy transition phase. So there is a lot of materials that you need for this energy transition. And if people consider wind turbines, for instance, there is a lot of materials in there besides construction materials, besides rare materials, for instance, magnets, rare earth minerals, etc. You have the steel that you need, which is made out of iron ore, probably. So there is more than just the coal mining or the construction materials in that sense here in Germany, if you look at it globally. And if coming back to the mineral processing, you're totally right in saying, hey, nearly every material needs some treatment before you can get it, right? And before you can make something out of it. And just taking the example of copper, nowadays copper deposits contain max 1% of copper. That means if you have a rock of that size, you need to process it, you need to crush it, you need to grind it, you need to classify the valuable material from the non-valuable materials, or to sort it, to separate it, indeed. And that's what our job is all about, and that's where our challenges are all about, because we are dealing with decreasing ore grade, with increasing depths of those pits that you're just referring to in Africa and Australia, for instance, and as such, I guess there will be challenges for upcoming students and mining engineers as well to meet those challenges and to find solutions for getting the materials out.
So do you think the processing part of the process is going to become more important in the future because of this lower grade ores that are coming?
I think it's an interdisciplinary challenge, because we are talking about the extraction of materials. We might talk about selective extraction, also if we consider gold veins, right, which are very thin in the deposit. They have to be mined, and once they are mined, they will come to us as processing engineers to process them. And as such, I see that more as an interdisciplinary action to look at the optimization of methods and methodologies instead of as a singular island.
Yeah, to working together.
Yes,
it's a critical part. So there's a lot of research and development going on in this space. Can you give us some insights on what's being planned here at RWTH Aachen in the advanced mineral processing technology space?
Yes, I can do. Well, there is a lot in the traditional mining and mineral processing space. So if you look at ores, like I said before in a question about the copper ores that need treatment and separation technologies to be further developed. But when you look at also the German landscape of research and development and the European landscape of research and development, critical raw materials become more and more important. The availability of those minerals become more and more important, but also looking at it from a different perspective, not only on the primary deposits, but also on secondary or alternative deposits for raw materials. And that, for instance, is reflected here in projects about slags, for instance. So steel making factories producing quite a lot of slags, and there are still valuable materials in there, like iron, like vanadium, like phosphorus, that we are trying to extract and to get valuable materials out of that. Second of all, there is also materials from secondary resources that, for instance, not only not necessarily my institute is looking at, but where recycling plays a pivotal role in getting and extracting those materials from the products.
Creating a circular economy, if you like.
Indeed, yes.
So where do you think the European mining course students, where do you think they fit into this? How do they, what would be interesting for them in learning more about mineral processing?
Well, from a perspective of a mining student or an EMC student, I think you will be very well educated in such a program, because you get a quite interdisciplinary education within your studies. That means you are looking at extraction methods, you're looking at processing methods, you might even look at metallurgical methods in the different study programs and lectures, and the mineral processing plays in that sense a pivotal role, that it combines that extraction with the metallurgical part. Yeah. And
joins them together and links them together.
Indeed, link them and building a bridge or bridging those two disciplines. And that is what I see in the first round of courses right now that I'm attending this year. That we do quite some practical education as well, right? So connecting theoretical lessons and lectures here in the classroom with practical stuff in the technical center that you might have seen, as well as combining it with practical activities during the lectures.
Yeah. But if I just jump to kind of the next question that I have, which is really about collaboration between the university and industry, because you have this off-site lab which is directly on a customer site effectively, or an operational site, where you can really do operational tests, right? So you can do an experiment and find out if it works in the real world.
Yes. You're mentioning it's actually a laboratory sandbox in a sandbox, I sometimes say, right? Okay. Because it's in a kind of quarry next to Aachen over here in Herzogenrath, and it's operated family-owned business, and it's actually a sandbox. So they are providing and mining sand and gravel for the local industry over here. Yeah. And we have a joint action there within our RWTH Aachen Institute called AMT. Professor Clausen is running that institute, as well as the local partner over there. So this laboratory sandbox allows us to transfer knowledge from the lab, from our technical center, into real-world mining environment, basically. And I guess this is quite a huge benefit for us, and shows how close we are to the industry. So we are trying to bridge the gap between fundamental research in the lab towards industrial applications in the real world. And like I said, the laboratory sandbox offers us quite some opportunities to do so, to do this transfer.
So could you give us perhaps a bit of a rundown of what's in the lab, what type of experiments you do, and what sort of equipment do you have there?
So additionally to our technical center over here in Aachen at the spot, we do have that laboratory sandbox, and that contains both the mine itself as well as an additional hall where we can build up additional experiments. So we do have the opportunity over there to build entire processing chains. So starting with a small crushing device, classification, different sorters in small scale, where we can also operate small process chains instead of just looking at it batch-wise, what we usually do here in our lab. Besides that, like I said, we do have the opportunity to go into the real plant, we collaborate quite close with the local partner, and that gives us opportunities, for instance, also to run bachelor thesis, master thesis topics quite in the plant.
Oh, fantastic.
And that's, I guess, pretty nice for the students to get into a real application and not only working on the lab side of things. And
that's very good.
We just recently did that with one of the bachelor thesis workers that I had over here, who was there, I guess, for 2-4 weeks, something like that, doing experiments in the field, coming back, doing the assessment of the data and evaluating the data, and then writing down his bachelor thesis. So quite a good opportunity.
Yeah, that's a very good opportunity. So what benefits have you seen on site from the research that you've been conducting there? Have they been able to make some operational changes or make some operational improvements?
Well, honestly and transparently speaking, not yet. But I guess that is more related to, like I said before, I'm just now in that position for 1.5 years. And also looking at the direction of the Institute, I will keep what has been good so far under my predecessor, and we'll add some topics like process optimization, we'll add topics also like digitization here in the Institute. And one of the first projects that is actually going to start in the middle of the year is one project about process optimization, where we want to have a look at the combination of different equipments, utilizing the data, transforming that data into information and recommendations. And then that is part of that roadmap, I would call it, to develop not only the Institute, but also the future engineers with those disciplines in data analytics, in process optimization. And so far, I guess that will be the first project that will have an impact on that route or on that topic within the Institute.
Yeah. So is that a constraint that you have today, that you don't have that capability, or what other constraints do you have, and are you planning on developing the lab further to create, like you were just explaining, create new opportunities for either learning or research?
Yes, we're going to try to enhance the capabilities in the near future of the AMR. So just to put a few figures next to it, I inherited approximately 70 types of equipment over here in the technical center with different size, different focus, which means they are in the comminution space, in the classification space, as well as equipment for sorting and separation of materials and the flotation lab. And as such, what is still, not saying a little bit missing, but I guess what we could improve in the near future is the analytical capabilities that we would like to put a spot on in the near future.
Yeah. And is that a constraint today, or do you have some real constraints other than, obviously money is always a constraint, right? So.
Yes, the constraint is, in my point of view, at the moment we are collaborating with different institutions, which means we are sending out materials, getting results, etc. But we also want to get the capabilities of doing that our own, also with regards to critical raw materials. You want to keep the knowledge, you want to enhance your own knowledge instead of being reliant on different institutions.
Yeah. Now let's pivot towards why the university is collaborating with industry, and why building a career in the industry could be interesting to potential students and budding entrepreneurs. I often talk about how education and research projects are the gateway to the industry, but perhaps you could start off by giving us some background into why the university is making such a strong connection to industry.
Yeah, so if we look at our connections here, we are still quite close to the Ruhr area, for instance, where a lot of OEMs of mining suppliers are located and based. So our challenges are real-world challenges that are being discussed with those companies, and as such our projects are also often with those companies. And this is a nice bridge, because we are getting the real-world challenges, we are looking from a methodology perspective on those challenges, and we are trying to find solutions for those challenges. And that is where the educational part also fits in terms of projects on master thesis, on bachelor thesis, and so on and so forth, and also of high relevance, right? So it's not only theoretically being addressed questions, but real world problems, so to say.
That links perfectly with the concerns that many students face. Is, they worry that the the thesis project that they do or the lab work that they do has no real connection to a real world problem. So your connection to industry, of course, is helping that overcome that issue, right? So it's much more relevant for their future career if they're working on a real world problem.
Yes, and it also increases the motivation to work on that solution, because you're really working on something that you can have a big impact in the future with. Like I said before, we had a project in our laboratory sandbox where we did an investigation within a bachelor thesis project, and that is now resulting probably in a project where we do some process optimization based on the results that we have gathered or that the student has gathered during this experiments and analysis.
Yeah,
so, and there is more than that. Not only that was just one particular that was just finished a couple of weeks ago, but there is more than that, because I usually, when I talk to partners from industry, to companies, they are 9 out of 10 saying, hey, we are looking for engineers, so we are looking for students of mining engineering. We are offering bachelor or master thesis projects, also with a view and a long-term view on hiring those people afterwards. And these connections are really important, not only for us as an institute, but also for the mining engineers or the people studying mining engineering, for instance, here in Aachen.
So what advice would you give to a student when they're picking their thesis topic? Making sure it's relevant, for example.
Yes. Well, first of all, it has to be fun. Sorry to say it like that, yeah. But it should be a topic that you can identify with and that you are able to work on 6 months or 4 months, depending on the project. Yeah. But you should look at it. Does it meet your interest? Does it meet your capabilities? Can you be passionate about it? So that is something you should look at first, in my opinion. And once that has been ticked in a box, you could look at, hey, what is something I could imagine work on in the future? So am I willing to travel a lot? Do I want to work more in a sales or more in a technical direction? And so you can also steer your research or your thesis project into that direction. And at the end of that 6 months, you will know whether you have done the right choice and going further with that intentional target, let's say, yeah. Or whether you say, well, that was something in the direction of XYZ, but I don't want to continue with that, yeah. And I'm going to go for something else. So, my opinion is really looking for something that could you feel passionate about it.
And of course, your own experience, from your working life with Royal IHC and WEAR, they'll give you some insight into where university research projects fit into industry. Perhaps you could give us share some of your historical experience, related to those projects, and also maybe just outline whether you think the mining industry is a good space for entrepreneurs today.
Yes.
Transferring this knowledge from kind of university to a real world problem and making some money out of it.
Yes, you name it at the end of your question. The driver in the industry is always a business case. So when you are coming from a university, and especially me, did also some PhD time after my studies, where let's say the focus was on methodology, was on technical developments, etc., not that necessarily on the making money out of it at the end of the day. So that was a challenge that I had to face first when I came into the industry. And that was basically the first questions. You can have good ideas, you can have brilliant inventions in your head, but the first question is, what money can we make out of it? And so you have to relate that, and that's something I had to learn during my time. Connecting that to the education again, I think we prepare students and giving them or providing them with a big toolbox of tools in different disciplines during their studies. Like I said, it's a very interdisciplinary study program, the mining engineer or the EMC program as well. But you start and you continue learning in the industry from day one. So you get into interactions with different groups, you get more and more into interactions with different disciplines. And from a technical perspective, I think, like I said, a mining engineer or a mineral processing engineer knows quite well about the processes. And me working, for instance, for an OEM, brilliant mechanical engineers, brilliant electrical engineers, brilliant data scientists. and also brilliant mining engineers, but bringing all those disciplines together for this mineral processing process or for the mining process, that was one of the challenges, but was also the fun to talk about these topics more in detail with the guys from the different disciplines.
Yeah. So where do you see the biggest opportunities for kind of new business entrants today in this mineral processing space?
With the studies you do in mining engineering or mineral processing, you get a quite broad spectra of education in different disciplines. You learn fundamentals of mechanical, electrical engineering, data science, legal aspects, economic aspects. So I think you have a quite broad knowledge, let's say, or education. With that said, I just met one person at the beginning of the year in Leoben, which is now working for a big European bank and is basically working on securing those mining and mineral processing projects for the bank. Besides that, and then looking at my own career, I mean, I went into industry after the PhD, first to Royal IHC, which was with regards to mining more in a consultancy role and doing innovation projects within that team of IHC Mining. But then looking at, for instance, Weir, I was one of the processing or mining engineers in Weir. Besides a lot of mechanical engineers, electrical engineers, data scientists, which are
working part as a team, yeah.
Indeed, which are very common for OEMs. So there is quite a lot of opportunities that you can have when you finished your studies.
So the last topic I want to discuss is really this traditional perception of the mining industry. So a lot of people see it as a kind of a bad thing, but that perception is slowly changing. How is the Advanced Mineral Processing Technologies Department helping to shift the narrative towards mining being kind of necessary, smart, and environmentally conscious?
Yes, that is a very good question, and I first of all want to relate that also to my experience in the past 1.5 years with our students, because I mean, when I did my decision for mining engineering, let's say 15, 20 years back approximately, there was a lot about, hey, it's big machines, it's a big industry, it is something international, so that were my motivations back in the days. Nowadays, you often hear, hey, we want to change something. We want to change the world, we want to change the methods, etc. And we want to become more sustainable. We want to work on that circular economy topics, etc. And that was a quite positive experience I made now with that new role. That being said, also our motivation here in the Institute is pretty much about using less energy, using less water, so working on innovative methods that are focusing dry processing, for instance, working on energy optimization. So, I mean, it's not a secret that 3 to 4% of energy consumption in the world is being in the comminution and in the grinding of materials, making big rocks small. Yeah. So the small the impact you can get, the better the effect will be on that number. And like I said, this is our motivation.
So you can affect the big number, right?
It is, yeah, indeed.
If you make a big change, you can affect the big number. Yeah.
Indeed. So looking at that, perspective, I think there is quite a lot to do in the upcoming, I even say, decades within that institute.
So what's your message to students that care about the climate, sustainability, or innovation, but might not have considered mining as a career path?
If we talk about climate protection or sustainability, etc., I guess mining has a big impact on that, because yes, we are moving a lot of rock, we are moving quite some materials within our processes, but if we can change something small, it can have a big impact. And like I said, my experience with the students is that some already had that perception to change. But I think on a lot of students or pupils, let's say, that are looking for a career path and so on and so forth, mining is maybe not that big on the landscape, right, of their choice. And as such, I can only recommend everybody to look at that, to see what opportunities this interdisciplinary education could offer somebody. and maybe do an internship or do a day of having a look at this industry, maybe at an OEM, maybe at a university, to get familiar with it. Because like I said before, everything starts somewhere with raw materials.
Yeah.
And
If you can't grow it, you have to dig it, right?
Indeed.
Social license to mine is another critical aspect today, and mineral processing is critical to every mining operation. Perhaps less obvious to the public because they still have this view of a large open pit mine and they don't think about the processes that come afterwards. But perhaps you could give us some insights into the research you're conducting and what programs that you provide that can enable mines to become more transparent, gain more community trust, and help them gain a social license to operate.
So if we look at the social license to operate, I guess we are contributing and optimizing the methodologies of processing further and further, utilizing new methods like data and information, like data science and so on and so forth. I guess there will be still quite some potential to optimize the entire process, to mainly focus on using less energy, using less water that is required, and then also to process, for instance, the water that we are using and having the smallest impact possible with the processing plant and with the mining operation itself.
And lastly, thinking about what the future holds for the mining industry in Europe, how can RWTH and its partners collectively help to accelerate the transformation towards a cleaner, smarter and more sustainable European mining industry?
Yeah, I think if we look at the global challenges right now and also the security of raw material supply to Europe, to Germany, etc., I guess we have a quite important role in contributing from a university perspective to that industry. So working further on methodologies, you name it before, like for instance for rare earth elements processing, but also for other materials that we are currently looking at, which might be of strategic relevance and also critical for our developments in the industry. That is where we play, I guess, a pivotal role to secure those supply chains, but also to secure technology knowledge within our own country and continent. So, and that being said, we are supporting the mining and recycling of domestic resources with our research. We can enable new technologies to be implemented in that industry, especially with the industrial partnerships that we still have with our OEMs, for instance, here in Germany, but also all over Europe. And also to bring in new innovations to be at that forefront to enable smart, sustainable and intelligent mineral processing at the end of the day.
Thank you, Tobias. It's been thanks for sharing all these insights, and I really appreciate the time you've given us, and I enjoyed the conversation. I also hope that you, our audience, enjoyed our conversation and that you gained a bit more of an insight into the material processing department here at RWTH Aachen University. And if you enjoyed watching this and listening to our conversation, please don't forget to give us a like and hit that subscribe button if you want to see more. And until next time, bye.